All right, let's talk a little bit about function notation. That's what this video is going to be about, function notation. So functions are like mathematical machines. So I want you to imagine a vending machine. So a vending machine is like a function. It's a machine, right? So you see this little keypad right here. So this is where you input something, like maybe you type in A2 or something like that. And then what happens is the machine interprets that message that you sent it, and it does a little spirally thing, and your treat comes out, right? Out comes your treat. So a vending machine is a machine. It's very much like a function. So functions, and here I've got one right here. This is function f. All right, we're going to dissect this a little bit and talk about what each of these parts are. That's what all these brackets are for. So each function has a name, and this is the name right here. This is function f. So I'm going to put name right here, and that's important because sometimes we'll be dealing with you're dealing with problems that might have more than one mathematical machine in it, more than one function, and it's important to be able to differentiate between those functions. For example, we have one vending machine here. So if you told your friend to go down to the vending machine and plug in A2 and because you know what treat you want, and then out will come your treat. Well, what if there were two vending machines, identical vending machines, and you don't want the treat in the A2 on this one and the one on the right. You want the treat out of the A2 on this one over here on the left. So it's like, how do you differentiate between the two? Here you could say, oh, the one on the left and the one on the right. But when we're dealing with mathematical machines like a function, it's nice to have a different name. So maybe perhaps we could call this machine, if this was a function, we could call this machine machine F, and we could call this machine over here machine G. And then we could say, oh yeah, I want you to go down to machine F and plug in this value so I get out my output. Or I want you to go machine G and plug in, maybe you plug in, you might even plug in the same value, but maybe something different comes out because it's a different machine, right? So maybe the numbers inside are jumbled up from over here, and A2 in this machine means something different than in this machine. So it's important that we have different names for functions so we can tell them apart. All right, so this is the name. Inside of here, we call this the argument. Argument. And you can think of it as like the input. This is what indicates what we're plugging in, our input. So I'm going to put slash input. Okay, this is what we're the place where we're plugging things in. Over here on the so that's the name, that's the argument. Over here on the right, this is what we do with the input value, or what we do with the argument. This is like the internal wiring of the vending machine that tells it that, hey, when you plug in a code A2, we want you to spin the treat that's on the fourth row, fourth column over. Or we plug in A2, we want you to spit out, the treat that's on the first row, second column. It's the internal wiring of the machine, telling the machine, what do you do with that input? What am I supposed to do with that thing? So we call this the rule. And you'll notice over in this rule that we have multiple places for our input value. Okay, and we'll bring that up in just a second. So, and that's okay to have multiple places for an input value. That's not a problem. So what's going to happen is when we are done, when the wiring and all that stuff, it tells us what to do. And we calculate all this out. We now know what in fact, I'm going to kind of put this in kind of a box like this. Once we have figured this out, okay, this is our output value. It tells us what to do, okay? So it's telling us, which if it was the vending machines, which treat to send out, right? That's the output value. Well, you'll notice that with these equal signs, that means whatever's on the right is the same thing as on the left. So if this whole side over here represents the output value, then this whole side over here can also represent the output value. So this is saying, so together, I guess I should have done this in a different color. So we'll say output, blue, sorry, I like my colors. So this side over here also represents the output value. when you have the name of your function and the parentheses with the argument inside together. That can represent the output value. Now, all in all, this whole thing, we call this entire thing the definition of the function. Definition of the function. Okay, so this is this right here. This is how function f is defined in the problem that we would be working on. Okay, so let's try and let's see how this works. Okay, let's we gotta clean up some space here. Just a second. All right, let's come down here a little bit. So you can see it's the exact same function, just doesn't have all the colorful stuff around it. So we'll come down here and we'll kind of play around and see what happens. Actually, I kind of want to keep those in the picture. All right, so we've got let's just pick a number, any number we want. We're gonna do f. We're gonna figure out what f of 7 is. Nah, 7 is a big number. Let's not do such a big number. Let's do f of 1. Let's do f of 1. Keep it simple. So f of 1. Okay. So I want to figure out what f of 1 is. So what is the output to function f when I plug 1 into the argument? All right. So here's my rule. So everywhere that I see this argument right here, I'm going to plug 1 into that. So right there, and right there. So I'm going to do that down here. What I would strongly suggest doing, super duper strongly suggest doing, anytime you ever do these problems, you always replace that value right there, the argument, not only with the number that you're plugging in, but put that number in parentheses. Every single time it will help you out with the order of operations. So I'm going to do that down here. So I'm going to have my 1 squared, I'll put the 1 in just a second, squared times 3 times 1. Whoops, I didn't want to put the 1 in. I want to make my 1s blue just because I want to be special. Plus 1 plus 2 times my x value, so minus 5. So you know, basically all I've done is I've just treated these as blank spots to put these numbers in. So I've got x squared, so I'm going to 1 squared, 3 times 1, and plus 2 times 1. And now we just simplify this. Now you got to follow the order of operations. The order of operations are parentheses first, so deal with the parentheses. So parentheses, exponents, I can spell. Please excuse multiplication, my dear, division, and addition, and then subtraction. And really, these two you actually do at the same time. You just work from left to right. And same thing with these ones, left to right. That's the order they get done in, but that's all right. So with parentheses, let's take a look at our parentheses first. So I've got some parentheses right here. Let's deal with this. So basically what this is saying is I have to take care of this, this parentheses before I can multiply it to this number right here. Okay, I can't just multiply these two things together right here. I'd have to multiply it to both of them, and that would be taking care of the parentheses. But let's just take care of this right here. So I've got this right here. So I've got 1 squared times 3 times 1 is 3 plus 1 is 4. So that parentheses is taken care of. Plus 2 times 1, so that's going to be plus 2 minus 5. I didn't really need to put parentheses around that, so okay. 1 squared, so right here, here's a good example. The question is, do I multiply these two numbers together first, or do I have to square this number first before I multiply it? And if you look at the order of operations, you need to take care of exponents before you can multiply. So since there's an exponent going on in this problem right here, I need to take care of that first before I multiply the 1 and the 4 together. In this case right here, it's not going to matter much. Let me scroll down just a little bit. So we've got 1 squared is 1 times 4 plus 2 minus 5. 1 times 4 is 4 plus 2 minus 5. So 4 plus 2 is 6. 6 minus 5 is 1. So we've got equals 6 minus 5 equals 1. So we know that f evaluated at 1. So if I take function f, I plug 1 in, the output, this thing right here, is equal to 1. It's kind of cool. We plugged in the number and we got the same number out. So that's f evaluated at 1. Let's try another one. Same function. Let's do the same function. Let me, well, we'll keep that up there. We don't need to erase it. I'll just try to write a little bit nicer, smaller over here. So let's plug in a negative number this time. Let's do -2. Let's see what happens. So we're going to do f. So this is a new problem over here. F, I guess I can scoot it over now that I drew that line, separate it. This is f of -2. So anytime I see an input value, I'm going to plug -2 into it. So, and make sure to put parentheses around it. It'll help so much. -2 squared times 3 times the -2 plus 1 plus 2 times the -2 minus 5. So you see how that's the same thing here, except for instead of plugging in 1, we plugged in -2 into each of those spots. So let's see what happens. Once again, we can deal with this. We can also take care of this here too first if we want. -2 squared, that's a positive 4. -2 times itself is positive 4. Okay. Now I can't multiply that positive 4 to here until I've taken care of the parentheses, or unless I made sure I multiplied it inside correctly, I distributed it correctly, that's fine too. 3 times -2 is -6 plus 1. All right, you've got 2 times -2, that's going to be -4. So it's a positive 2 times -2 is -4, and then a minus 5. So right here, we got -6 plus 1 is -5. Minus 4 minus 5. It's -20. So once again, I can't subtract these two numbers from each other. I can't do -5 minus 4 because the -5 is being multiplied by the 4. And which one takes precedence over that? Multiplication does. So I have to do that multiplication first. So 4 before I try doing those two things. So it's not necessarily like, well, I'll come back to that comment in a second. So -20 minus 4 minus 5. And so -20 subtract 4 is -24. Minus 5 is -29. So f of -2 is equal to -29. So when I plug in -2 into function f, this is what I get out. When I plug in 1 into function f, this is what I get out. This tells me what to do with my input. It's the rule that I follow. So if you ever saw something like this, f of 3 is equal to what? What you would do is you would take the 3, you would plug in, you'd find function f and plug it into function f, into all the spots that the argument tell you to. Now, just a minute ago, I was saying, about ordering. Now, one of the I guess misnomers about order of operations, it doesn't mean you have to do all the multiplication in the problem first, or all of the parentheses in the problem first. It's just when you come up with two operations to the same value, like for example, let's come back down here. So let's come back to this scenario right here. Okay, I've got 4 times the -5 minus 4 minus 5. Okay, this -5, specifically this -5 and this -4 right here. The -5 is being multiplied by this 4, and it's going to be subtracted by this 4. So the question is, which one do you do first? Can I subtract 4 first, then times it by 4, or do I have to multiply by 4 and then subtract the 4? And the order of operations say you must do the multiplication step first. All right. Now, there's nothing wrong with, I could actually combine these two here together. This -5, what's happening? The -4 is being subtracted by -5. I can do that first. I can do the -9 first. So, I mean, I know it's kind of, and I don't want to confuse you too much with this and before we can kind of look at it together, but you just have to make, so just, I don't even know what I'm trying to say anymore other than don't get stuck. Well, I can't think what I'm trying to say. All right. Anyways, so that's kind of an explanation of functions, function notation, and we'll have to have a conversation about order of operations and what that truly means, not what people, kind of get confused about it meaning, but that is right there, function notation. So we have the name, because remember we could have multiple functions in the same problem. Like here we had 2 different vending machines. We needed names for both of them, so we called one F, one G. So the input value, by the way, can also be different. It doesn't have to be an X. For example, I could have said, hey, my function G right here, G is defined as I take the input value smiley face, and that's going to equal smiley face plus 5. and that is the definition of my function g. There's nothing wrong with that. So if I wanted to figure out what g of 2 was, I would plug 2 in for smiley face. 2 plus 5 is 7. So this value right here, the input, the argument, doesn't matter what the thing is. That's just what indicates what you're replacing with your input value. All right, well, that ends this video. I hope it was helpful, except for the part where I kind of stumbled over myself trying to talk about the order of operations, so I'll have to go over that later.